Okay, now that we have our two sketches here, we can go ahead and start extruding. So I'm going to hit extrude, and I'm going to extrude this back feature here first, and that is going to be 80 millimeters tall, so we can go ahead and hit enter, and we can see here that it extrudes it. And then next we're going to extrude this section right here, so we can see that it highlights just the part we want extruded, and that is going to be raised to 30 millimeters. We go ahead and hit enter on that, hit OK, and we can see from here we've got the nice shape going that we want with the nice cutout going on. Alright, cool. So then the next thing we can do is go ahead and do the two holes. So we're going to need a front view for this, and we're going to Hello, welcome back fellow women machinists. Welcome back to our OnShape training. This is our practice part drawing video number 2. And today we're going to be learning how to do another practice part. So last week we went over this part here. That was in our previous video. And today we're going to be going over this part right here. So some things to keep in mind we'll be learning today is how to chamfer and how to drill with some countersink holes. So let's go ahead and get started. Alright, so we have our document here set up on OnShape for our part practice number 2. And the first thing I'm going to do is, just like last week, check our workspace units, because it's automatically set to inches, but all of our part drawings from this Autodesk Inventor Practice set are in millimeters. We're just going to go ahead and put it in millimeters for convenience. Okay. So the first thing I'm going to do is pick the top view and go ahead and draw the base cube or square of our part here. So go ahead and sketch. I'm going to sketch with the top view. Click on the top view so we can see it clearly. And then the base of our rectangle here is 60 in depth. Okay, well, let me first draw the rectangle, that would help. So go ahead, draw a rectangle, and it looks like it's 60 in depth. Oh, let me escape the sketch, then dimension here. It looks like it's 60 in depth. There we go. And then it's 30 plus 45, 40 plus 35. So you can go ahead and do that math in your head, or, no, I don't want to dimension that, I want to dimension this length. So anyway, so you can either do the math in your head, or you can just type 35 plus 40 plus 35, and it'll do the math for you. Easy peasy. Alright, cool. And then what I'm going to do to add to this sketch, like I did again last week, is because two different sections will be raised to two different heights, I'm going to go ahead and draw a line so that when I do, what's the word for it? When I do extrude it, it's going to make it a lot easier. And this is set, let's see, 25 from, so let's go ahead and dimension that. Alright. Now we have our first sketch here, and now we have two options to proceed. We can either draw in our sketch now of like the cutout we're eventually going to do when we extrude, or we can wait and draw it on the surface after we extrude. I personally like to have all my sketches in at the beginning, so I'm going to go ahead and sketch it now. And for this one, I would recommend just doing lines instead of drawing the box, so that way you can dimension it an appropriate distance from the other lines without having the constraint of it being a rectangle. So first, the distance from here to here is 35 millimeters, and then we want to mirror that on the same side. And now, since we've set up this shape, the length of the entire rectangle, this will automatically be 40. And if we add the measurement right now, the drawing will become over-confined because we've already marked the entire length of this rectangle. So just adding the 40 will over-constrain this part, and we'll get a bunch of errors from OnShape saying we've put too many limitations on it. Cool, and then this height here is 25. Alright, so now we have our sketch here fully defined on the face of the other sketch. Okay, now that we have our two sketches here, we can go ahead and start extruding. So I'm going to hit extrude, and I'm going to extrude this back feature here first, and that is going to be 80 millimeters tall, so we can go ahead and hit enter, and we can see here that it extrudes it. And then next we're going to extrude this section right here, so we can see that it highlights just the part we want extruded, and that is going to be raised to 30 millimeters. We go ahead and hit enter on that, hit OK, and we can see from here we've got the nice shape going that we want with the nice cutout going on. Alright, cool. So then the next thing we can do is go ahead and do the two holes. So we're going to need a front view for this. It's time that we're going to drill the holes in it. So we're going to go ahead and add a sketch on this plane, and then we're going to go ahead and click on the circles. And so we're going to add a circle right here, and then another circle right here. Alright, cool. And so when we're dimensioning these, when you're dimensioning a hole, you need three different kinds of measurements. You need if you imagine this as an XY plane here, so you need its X direction, its Y direction, and then its depth, or anything like that. So yeah, any of the information about the hole itself, the sinks, anything like that. So X, Y, and the depth of the hole. Those are the three measurements you need. So first, our radius of our hole looks like it is, oh, I had it clicked, okay. Let's see, it says diameter 6 through, then it has a little like square symbol, or let's go ahead and escape this and take a look at what I was talking about here. So right here it says this is the diameter symbol here, 6 through, then it has this symbol which means a countersink, 12, 5 deep, and then 2 place. So that means 2 place, first of all, starting from the bottom here, this means this is true for both of the holes. 6 through, that means that the diameter is going to be 6 all the way through. And then this countersink, which is going to be 12, which is like double the diameter of the through hole, and it'll be 5 in millimeters. I might be saying inches, I meant millimeters for all of these. 5 millimeters into the hole that we've drilled, or into the surface. So this needs to be 6 millimeters, as well as this one. And then when it comes to dimensioning holes, there's two ways to do this in terms of like doing the X and Y direction. So first one we can do is start with like a zeroing point. So let's imagine this is our 0, continuing this X and Y analogy here, if you're imagining like a plane, an XY plane happening here. We're going to go ahead and measure the X direction of this circle here, and we need it to be 30, and make sure that we're clicking the center. It's 30 from the center, not the edge of it. Okay, cool. And then we need the Y direction, right? So dimensioning from the circle to this line. Oh, sorry, I need to do the Y direction. From the circle to up here. Okay, 25. Cool, so we have this whole dimension right here. We got its depth, we have its X, and we have its Y. So now, dimensioning this hole, we don't want to dimension. We could, okay, so we could start dimensioning it the same here that we did on this side, reflecting it on this side and dimensioning using these lines. But the reason we don't want to do that is because when we have to machine this part, which you will learn later on how to machine if you haven't had that experience yet, but we have to zero a point on the machine. So if we're going to be drilling this hole, we're going to need you put our drill bit against the edge of a part, and we mark that as our 0, so that when we move our drill bit, like, you know, the 30 millimeters that we need to so we can drill this hole, this is our marker, like 30 millimeters from this point. So if all of a sudden we start measuring from this side for this hole, then the machinist is going to have to all of a sudden re-zero their machine, and instead of using this line, then they're going to have to reset up their part so that the 0 starts from here, and then the machine will count 30 millimeters this way. And that is just not efficient, not a good way to set it up. So we want to use the same line, like the same axis. Imagine this being the x-axis, this being the y-axis. We want to measure from these lines and not pick a new axis to measure from. So with that being said, we have two ways to do this. We can either do measure this hole along the x here from our x itself, so that way we have another one, like, because it's measured 30, 50, so you can do that and have it set to 80 like that, and then you just know from this 0 you should go all the way to 80. Or another way that you can do this is you dimension from this hole, oh, I don't have the dimensioning clicked, from this hole to this hole. And the reason you could do that is it's this method's called like a cumulative method. So once you get to this point, which you're going to have marked out on your machine will know you've gone 30, and then you can go another 50 from there, and you don't have to like restart from the 0, or you're not making the machinist do the math of like 80 minus 30. Either way works, as long as we're, like I said, emphasized again, using this as our reference point as our 0. And then we're going to go ahead and measure the y direction of this as well. Oh my goodness, sorry, y direction. Here, and set it to 25. Cool, so now these two circles are in line, and they're dimensioned from the same axis, and it's easy for the machinist to go ahead and machine this part. The next thing we are going to do is we're going to add the circle, in addition to these circles, that's going to eventually be the countersink. So I'm going to go ahead and add a sketch of a circle, making sure that my center is the exact same center as the other one, so that way the holes are lined up when I dimension them. So let's go ahead and dimension this diameter, which is 12, and this one will only be going in 5 millimeters, while the 6 millimeter diameter hole will be going all the way through. So I'll show you how to do that in a minute. So go ahead and click OK on this sketch. And now it's time to extrude. So when we hit the extrude feature here, what we're going to want to extrude is this one and this one, and we're going to want to remove. So click remove, and you can do through all like that. Clicking through all means it's going to go through anything that's there. Even if we had several layers of stuff, we're going to just cut through all of it, and we're going to hit OK. And as we can see here, now the hole is all, here we go, front view. Then we got the hole all the way through. Okay, so now going back, we're going to make our sketch 3 visible again because now we need to extrude the countersinks. Yeah, so the reason we have this countersink here is because if you've ever screwed anything in, if you've ever used any tools, as you know, the head of the screw is bigger than the threaded part of the screw, right? So if we want to not have this screw kind of emerging from the surface of our part, we want it to be like a smooth surface, we're going to have like this countersink happen so that the very edge of the surface is smooth. You won't have that screw bulging out. And so to do that, we're just going to go ahead and extrude once again. Click the larger circle shape. If it lets me just click the circle. And then it's going to be a remove, and the depth is only 5 millimeters, right? It said 5 in. 5 millimeters. Okay. And we click OK. And you can see here from this angle, it doesn't go, these countersinks only 5 millimeters in, and then the rest of the hole goes all the way through. Okay, so now that we have our part, the last step is to add the chamfer and the fillet at the top so that we can make these edges. We kind of want to cut off these edges. We just want to cut off these edges here and then round these corners. So this feature is found, hold on, I'm readjusting my screen, right here. So we have the chamfer, we have the fillet. So as we can see here for our chamfer, which is we're going to do to right here, on this part here, it says 3 times 45 degree chamfer. So that means the degree is 45, so there's going to be a perfect cut on each side, and they want 3 millimeters off. So we're going to go ahead and hit chamfer here. What we actually want, so we don't want, first let's click on the entities to chamfer, which will be this line right here, this line right here, this one right here, and this one right here. Now they're all going to be do the same chamfer to it, but we don't want an equal distance. What we want to set is the distance and angle. So the angle is going to be 45, but the distance is only going to be 3 millimeters. So after we've done that, we can go ahead and click OK. And as you can see here from the front view, let's take you to a top view here. We've got the nice chamfer edges like we do in our part drawing. Okay. Now our last step is our fillet here. Hold on. Okay, so now we've added our chamfers here. So now it's time to add the fillet at the top. And the difference is between chamfer and fillet here is this is just literally just cutting off the edges. I mean, we still have, you can kind of see from this picture here, we still have like that sharp kind of angle to it, but we've just literally cut off the tip. Whereas for a chamfer, we're going to be rounding out this edge here. So first we want to, readjusting my screen here, what we want is we're going to click on the fillet option right there, and then we want just this edge and just this edge right here. And now in our part drawing here, it says R6. That means we want a radius of 6. So as you can see here, its cross-section is a circular. You have a lot of other options, but we want it to be like a circle, like literally just rounding off this edge. And our radius is going to be 6. Hit OK. And now we have before ourselves the nice finished project. Here's an isometric view of our part. In case you missed how I did that, you click on this here. And then isometric is like the nice angle where you can see the front, the top, and the right view all at the same time. So this is our nice finished part here. Top view. So yeah, that was our training for this week. If you have any questions, don't be afraid to reach out, and just keep up the good work.